In this unit, we will discuss electric charge. Electric charge is intrinsic electrical property of subatomic particles, and charge is represented in units of coulombs. Here is a model of an atom. You can see protons and neutrons reside in the nucleus of atom, and electrons revolves around nucleus. Electron carry negative charge, whereas proton carry positive charge. Neutrons are neutral particles. The charge on electron and proton is equal in magnitude, which is equal to 1.602 into 10 to the power minus 19 coulombs. Law of conservation of charges. Law of conservation of charges states that charges can neither be created nor be destroyed. They can only be transferred. It means the algebraic sum of electric charges in a system does not change. Electric field. Charges of opposite polarity attract each other, while charges of same polarity they are repelled. In this figure you can see if you put two neutral bodies together, they experience no force between them. If you put two oppositely charged bodies together, they experience a force of attraction. If you put two similarly charged bodies together, for example in this case positively charged bodies, they experience a force of repulsion. And similarly, if you put two negatively charged bodies together, it means they have the same polarity of charges, they experience force of repulsion. The force which acts between charges is called electric field, and it is represented by imaginary lines. Here in this figure you can see there's a collection of positive charge, and here is a collection of negative charge. So if these collections of negative and positive charges they are separated by some distance, you will have a force of attraction between them, and that force is called electric field, and it is represented by these lines of forces. These are imaginary lines of forces which represent the electric field. 1 coulomb is basically a very huge quantity of charge, and it is charge carried by 6.25 into 10 to the power 18 electrons. Normally in laboratory we experience charges on the order of picocoulombs or nanocoulombs. The equation for charge is this: Q represent quantity of charge, which is equal to number of electrons divided by 6.25 into 10 to the power 18 electrons per coulomb. 6.25 into 10 to the power 18 is the total electrons which carry 1 coulomb charge. So using this equation we can calculate the total charge if we know the number of electrons, or we can calculate total number of electrons which are required to produce a given charge. So here in the next section we will put this equation to use. So here is one example for you to calculate. So you have to find out total number of charge represented by this quantity of electrons, which is 93.8 into 10 to the power 16 electrons. A hint for your calculation, you can use the equation for charge. Here I will take a pause for a while so you can do your calculations. Here is the result which you can get by applying the equation for charges. So we are given 93.8 into 10 to the power 16 electrons, and the quantity of charge present on these number of electrons is equal to 15 into 10 to the power minus 2 coulombs, which is also 0.15 coulombs. So this is our basic discussion on the behavior of charges.